Okay, so map slash transform points and functions via matrices. This is going to be the 7G, 7H. The reason I've got map or transform, you can use either of those two words. It means essentially exactly the same thing. Cool, so what are we talking about? Okay, we touched on matrices last time. I'm just going to define some matrix X as being two coordinates of some point on the Cartesian plane. So we've got x, y. Great. I want to take that, do something to it, and shove it somewhere else. So that's new position. I'm going to call x prime. Okay, prime just means something different. Beautiful. Okay, so we've got x prime and y prime as our new guy. The fancy words for this, you have pre-image for whatever you started with, and the image is whatever you get in the end. Beautiful. We're going to do that via some matrix fiddling. T is going to be our transformation matrix. I'll run through the A, B, C, D, what they all do as we go. And S, I've just picked another letter. That's going to do some other stuff, so I've got H and K in there. We'll always, for year 11, we'll always run through this one. But having said that, I don't even think this comes up when we do functions for year 11. I think it only comes up in 12. You're welcome to do it though. Cool, so our new thing is going to be some transformation of the original plus an extra bit. And I know that's nice and vague currently, but we'll work it through and it'll make a bit of sense. It is possible to do it, make this shift and then make this transformation as well, but like I said, for now we're just going to do this one. It makes no real difference in the end. Just so long as you, doing it this way versus doing it this way makes it different to what this endpoint will be, but your processes are analogous. Great, so I want to run this transformation on some point. So let's say I'm going to pick a point, nice boring point, 1, 2. Okay, I want to run this transformation on it, so this matrix is going to be to the left of it. 1, 0, 0, 1. Cool, and that's going to equal my new position matrix. Great. Well, let's run that through. Probably should have done that in blue, doesn't matter. Cool, this matrix times this matrix, so you can shift this down, run it all through, and hopefully you'll end up with matrix 1, 2 again. So in this case, the image and the pre-image are the exact same. Well, why did we bother to do that? That was just to point out that, oh, what kind of matrix is that? That's an identity matrix, a 2x2 identity matrix. Great, identity matrices should, whenever they're applied to anything, do nothing, leave it alone. So great, that works just fine. Okay, well, let's take this same point again. 1, 2. Now we're going to add on this extra guy, 0, 0, and unsurprisingly, we end up back at 1, 2 again. So this transformation and this shift do nothing. They're nice and boring. Okay, well, let's try the other guys. So we'll take that same point as before, 1, 2, and we'll multiply it by 0, 0, neg 3. Great, okay, I'm multiplying these. What do we get? Cool, so you can rewrite these if you want, shift that one down, go as far away as you can. 2 by 1, 2. Add 0 by 2 is 0. Next line, as far as we can away, 1 by 0, 0. Negative 3 by 2, negative 6. So we end up with 2, neg 6. Great, okay, so we've actually moved somewhere this time. Our x changed from 1 to 2, and our 2 changed from 2 to negative 6. Hopefully we can see this transformation, all it did was multiply the x by 2 and multiply the y by neg 3. Cool. And we'll make a bit of a general statement then. Cool, this thing has taken this point and just multiplied it by 2. So if I think of x coordinates, and I'm pushing them by a factor of 2, that's the same as dilating by a factor of 2 in x in the x direction. So we've dilated it by a factor of 2 in the x direction. So if this was 5, everything gets 5 times as far away from the y-intercept. So everything's getting dilated. Brilliant. Well, this guy, we went from 2 to -6 when we multiplied by -3. That all makes sense. So this thing, it's going to dilate by factor of, and I've just realised what I've said, that should be an A, this should be a D. To make it nice and general. Alright, the D is going to stretch everything vertically. So, factor of D in the Y direction. Beautiful. Okay. Cool, well what does this guy do? Well, since we're adding them, let's just take this to -6. This truck goes by. Oops. Cool. This is just nice and straightforward adding. 0 and, was that -1? Cool. Well, I went from 2 to 0 for my x coordinate, so I've just shifted to the left by 2. This guy, is that what I've done? Make sure. Yes, this was -2, so that's fine. So we translate whatever letter it was, h units in the positive x direction. Beautiful, and unsurprisingly, similar thing for the k. K units in the positive y direction. So if what letter have we got? H. If h is negative, then we're going left. If h is positive, we go right. If k is positive, we go up. If k is negative, we go down. Beautiful. Done, 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 done. Yes, great. So that's nice and straightforward. Okay, well that works if we're on this diagonal. What happens if we're on this diagonal? Well, let's pick... we'll just do this with a generic xy. Multiply by this guy. Cool. And this now equals x prime, y prime. Cool, as did all of these. Okay, well, this multiplied by this, I get 0 for x and 1y, so I get y. Same thing, 1 for x, 0 for y. So I've got a position where x prime is now y and y prime is now x. So what's happened? I've switched my x's and y's. Well, we've already done that previously. So this guy will give you a reflection along the x equals y line. So in other words, it'll give you an inverse function, so long as it's a function. That's that, beautiful. Most of these, when you get points, they're nice and boring and easy. When it gets a bit more troublesome is when we start trying to transform not one point, because one point you just put it in, fiddle around with your matrix multiplication and addition, and it spits out a point, so you go from one position to another position somewhere. Easy, boring. What's more interesting is when you take an entire series of points, an entire function, run that through a transformation, and then it spits out an entirely different function, or relation potentially, but we'll stick with functions. Cool. Alright, so let's take a function. Okay, so I've got some function there. Let's do some smart things. What have we got? 2, 4, 2, 4. Beautiful. -2, -4. Cool, what's this? 0, 8. This is -2, 0, -4, 0. And down here we've got what? -3, -1. Is that right? -3, -1. Yep, cool. Cool, so that's what we're dealing with. Okay, fine. Let's run this through a transformation. So this entire thing is going to be my original xy. So it's not just one point, it's an entire line. All of these things are all made up into this xy. Okay, we're going to run it through a transformation. I'm going to let that transformation be this. Okay, so, well, how are we going to do this? We're going to leave things in this xy form. So remembering x prime y prime is going to equal my transformation of my original. We could do a plus s, so an extra shift on top of this, but we're not going to. We're just going to do one thing for today. We do the shift thing in year 12 more so, but it's all very, very similar. Cool, okay. Well, what do I get? Expand this out, I'll end up with x prime equals 2x, y prime equals 3y. Let's get a bit shabby, there we go. Cool, okay. Well, I don't know what x prime is, but I know what the original x's are. So what I'm going to do is say this is equivalent to x prime on 2. All I did was divide by 2. Similar story, y is equivalent to y prime divided by 3. Excuse me. So, we've got this statement. Well, conveniently, I know how x and y relate. So I can take this statement and then replace it with these. So y becomes y prime on 3. Y prime on 3 is now going to equal x squared, this thing squared, x prime 2 squared, plus 6 lots of x prime on 2 again, plus 8. Beautiful. Now this thing looks absolutely diabolical, but it's not that bad if we fiddle around with it. So, we've got y... now, at this point, I've got all primes and no originals, so I'm just going to stop writing the primes. I just have to remember, this is now in my new equation, my new position. Great. We'll leave that on 3 for now, until we match up everything else. Cool, this thing's squared, so we've got x squared over 4, plus x on 3, plus 8. Cool, alright, well that's not the worst thing ever, but I'd like to get rid of this 3 at the very least, so let's do that. So we get 3x squared over 4, plus x plus 8, make sure we're all okay. Yes, times 3, whoops. 24, that sounds better. Yep, cool. Okay, so we've got y by itself. Now we just have to figure out, well, what does this actually look like? Well, to make life easier, let's take that quarter out. And actually, let's take the entire 3/4 out. Or maybe we should do this in 2 steps. Yeah, we'll do it in 2 steps. Just so we don't lose anyone. Cool, took out a factor of a quarter, so I need a 4 in here because then 4 times the quarter will bring me back. And, yeah, alright. 96. Great. Okay. I want to get rid of this 3. That seems odd. Is that what I ended up with before? Double check. So we've got y divided by 3. Yes, x divided by 2. Yes, this on 2 is 3x. Is 3x, not x on 3. Whoops. Well, that makes life a bit more enjoyable. So we've got, what's that, 36 there. Cool, take out a factor of 3. That seems better. 12x, what did I take out? 3, so we've got 32. Yep, okay. Beautiful. Okay. Well, now I've got all this. Can I factorise it? Leave 3/4 alone. Cool. 2 things times this, add to that. 4 and 8. Okay, great. Well, let's draw this thing up. So we've got -4, -8. Something that crosses way up here somewhere at, where was it? What we got? 32 divided by, this divided by 4, so 24. Yep, 24, there it was. Cool. Beautiful, and a turning point, -6 something. -6, 2, -4, gets rid of those, -3. Yep, okay. Cool. So we went from this parabola to this parabola. Alright, how do we know that's right? Well, let's consider what this transformation was supposed to do from what we figured out before. Alright, all it should do is A, dilate by a factor of whatever A is. So it dilates by a factor of 2 in the x direction, so it should get twice as wide, and it should get, dilates in the factor of, by a factor of 3 in the y direction, should get 3 times as tall. Okay, well, we went from -3, -1 to -6, -3, alright? I should go further in the x direction by a factor of 2. Yep, that checks out. -3 went to -6. Should go in the y direction further by a factor of 3. -1 becomes -3. Yep, that's good. Cool. My two x-axes by a factor of 2. By a factor of 2. Yep. Y-intercept. Cool, by a factor of 3. Yep, everything checks out. Great. Last thing is, was I expecting this to change shape at all? It's like, well, no, if I've stretched this way and this way, then I'm still going to end up with some sort of parabola. So that's about it. Cool. So 7G is mostly this side, 7H is mostly that sort of side. Email me if you get stuck with anything. For now, cheerio.